So good morning. This is learning by observations. Basically, what we do is building AI system that learn from through the common sense. Our mentor was Neha and Professor Faizi.
Our team members are Vasundhara, Christina, Faria, Zoe, Marcella, Sulagna, and myself, Anushka.
In this project, we learned to train a simple self-supervised model on images and visualize that embeddings to show they are linearly separable. And we implemented a self-supervised model based on SimSailor and trained it on a dataset called CIFAR10, which contains 60,000 images from 10 classes.
So basically, self-supervised learning is instead of memorizing, we are learning or training the computer from the observations with the data. So this is process of learning without ground truth labels is called self-supervised learning. So goal of the project is perform image transformations to generate positive view and train those computers over transformed data and show that training loss is converging and training the linear classifier over generated representations and computing the accuracy of linear classifiers and visualize it to show they are separable.
So for our first task, we modified the code to prepare the training data for our neural architecture. After that, we applied certain data transformations for training purposes, like the horizontal flip, random cropping, and Gaussian blur. After that, we basically visualized these clean images from our data set. We got 2 transformed images for every clean image according to the transformation process that we used.
In task 2, we needed to convert the image to a vector which computer can understand. So we prepared the project head and also the encoder to encode that image to a form that computer could handle.
For task 3, we implemented a contrastive loss to compute our loss. In this loss, we basically tried to maximize the similarity between positive images, that is the images from the same classes, and minimize the distance between and minimize the similarity between images from negative classes. We used the formula shown in the screen and computed using matrix multiplication.
And also in this task 4, we are saying that our goal was that it will converge. So we are saying the loss is converging from the start and to the end, and that was our success.
In task 5, which is basically the 5th thing we did, that we essentially trained a linear classifier. As like actually training the SimCLR could take several days, we proceeded with a pre-trained model for the purposes of this project, as you can see below. Then our goal was to compute the accuracy of the model for the test set. To do this, we basically did the following. We iterated over the loader, we extracted the features from it, and we passed the same features through the classifier, and then checked if the prediction is the same as the true label or not.
Our final task was to visualize the representations and show that they are linearly separable in the latent space. As you can see from our result, we managed to find that they are linearly separate. To achieve this, we did the following. So we passed a few images through the encoder and extracted their representations. We then normalized the representations and used a dimensionality reduction method to reduce them from 2048 dimensions to 2 dimensions. After doing that, we plotted them in 2D space using matplotlib_scatter.
So as we went through, we had 6 different tasks to complete. The first one was preparing training data, and task 2 was prepare encoder and projection heads, and 3 was implement of contrastive loss, and trained SimCAR encoder, and then trained linear classifier and visualize it representations. So we start off by working together and then split our work amongst each other once we start getting more comfortable working with the code. So with using the PyTorch and NumPy and Matplot libraries, we learned to train simple self-supervised models of image and visualize embedding and show that they are linearly separable. Thank you.
Thank you.